Good morning, Geometry Honors class. So this is Mr. Chen again. So today I would like to talk about the biconditional statement and definition. So let's start with some of the warm-up problem right here. So this one basically just writing that the conditional statement from each of one of the following. The intersection of two lines, it's a point. So if two lines intersect, then they intersect in a point. An odd number is one more than a multiples of 2. If a number is odd, then it's one more than a multiples of 2. Write the converse of conditional. If Pedro lives in Chicago, then he lives in Illinois. Find its true value. So here's the one. If Pedro lives in Illinois, then he lives in Chicago. So it's a false statement. Objective for the lesson today, write and analyze biconditional statements. So here's some of the vocabulary. Biconditional statement, definition, polygon, triangle, quadrilateral. So when you combine the conditional statement and its inverse, it creates a biconditional statement. So a biconditional statement is a statement that can be written in the form of P, if and only if, the key phrase, if and only if, Q. So this means that if P, then Q. If Q, then P. So that involved with the conditional and the converse statement. And also that implies they're always true. Okay, so here's the logic. So write the conditional statement and converse within the biconditional. So an angle is obtuse if and only if its measure is greater than 90 degree and less than 180 degree. Okay, so let's just start with the hypothesis and the conclusion. So P, which is the hypothesis, Q, which is the conclusion. So P, an angle is obtuse. And Q, an angle's measure, it's greater than 90 degrees and less than 180 degrees. Okay, so once you come up with that conditional statement, if an angle is obtuse, then its measure, it's greater than 90 degrees and less than 180 degrees. Complete statement. Converse, if an angle's measure is greater than 90 degrees and less than 180 degrees, then it's obtuse. So identifying the conditional within a biconditional statement, so similar to what we just did. So again, anytime they see that the double arrow, one pointing to the left, one pointing to the right, so that means a biconditional statement. So again, set up the hypothesis, a solution is neutral. And conclusion, a solution's pH is 7. So the pH scale, biochemistry. So connect those two clauses together. So if a solution is neutral, then its pH is 7. And converse, if a solution's pH is 7, then it's neutral. So here's more example that you guys can try to practice. An angle is acute if and only if its measure is greater than 0 degree and less than 90 degree. Again, set up the hypothesis, the conclusions, and then connect those two clauses together with the conditional statement. Converse, we just swap those two clauses. So if an angle is acute, then its measure is greater than 0 and less than 90 degree. Converse statement, if an angle's measure is greater than 0 degree and less than 90 degree, then the angle is acute. So again, the biconditional statement always guarantee that the conditional and the converse statements are both true, always. Okay, so more example for this one. Okay, so that's something you guys can try. So here's another one, identifying the conditional within a biconditional statement. If 5x minus a equals 37, then x equals 9. So this one is given as a conditional statement. So you want to write the converse and the biconditional. So the converse would be if x equals 9, then 5x minus a equals 37. And then biconditional, so connect those two clauses together. So 5x minus a equals 37, if and only if x equals 9. If two angles have the same measure, then they are congruent. If two angles are congruent, then they have the exact same measure. Biconditional, two angles have the same measure if and only if they are congruent. Again, guarantee that it's always true. Okay, so here's more practice. More practice. So for a biconditional statement to be true, both the conditional statement and its converse must be true. Okay, so we talked about that earlier. If either the conditional or the converse is false, then the biconditional statement is false. So usually the biconditional statement is given with like the true statement. Okay, so now here's one of the contradictions. So if the statement is false, give a counterexample. A rectangle has a side length of 12 centimeter and 25 centimeter if and only if its area is 300 square centimeter. Conditional, if a rectangle has a side length of 12 centimeter and 25 centimeter, then its area is 300 square centimeter. Would that be a true statement? The conditional statement is always true. The way to find the area of a rectangle is always length times width. So 12 times 25, so there's only one outcome, 300 square centimeters. But what about the converse? If a rectangle's area is 300 square centimeter, then it has side lengths of 12 centimeter and 25 centimeter. Well, 300 square centimeter for the area, so that means the dimension, the side length, it could be any other lengths. It could be 30 and 10. There's so many selection. It could be 15 and 20. Okay, so there's so many counterexample. So the side length could be 10 and 30 centimeter. So once you find out one of the counterexample, so that means the statement is considered false. So because the converse is false, so therefore the biconditional statement it's also false. Determine the biconditional is true if false, given counterexample. So if a natural number, okay, a natural number n, it's odd. If and only if n squared, it's odd. Conditional statement, if a natural number, it's odd. Then n squared, it's odd. Would that be true? So let's just plug in a number. So let's say n is 3. 3 squared, it's what? 9. 5 squared, 25. So any kind of odd number, once you square that, it's always considered an odd number, another odd number. What about the converse? If the square n square of a natural number, well, this one's a little typo here. If that n square of a natural number, it's odd, then n it's odd. Would that be true? The converse is also true. So again, anytime that you cannot find any counterexample, so that means the statement it's always true. So since the conditional and its converse are true, then the biconditional is true. Determine the biconditional is true. If false, give a counterexample. This one's more practice. Okay, so guys can take a look at that. This one here. An angle is right angle if and only if its measure is 90 degrees. So the conditional statement is true. Angle is right angle, then its measure is 90 degrees. If the measure of the angle is 90 degrees, then it's a right angle, obviously. Okay, so here's another one. So y equals -5 if and only if y squared equals 25. Conditional statement is true. But what about the converse? Y squared equals 25, then y equals -5. Well, it's a quadratic equation if you take the square root both sides, so y could be +5 as well. Okay, so the biconditional statement is false. Okay, so in geometry, biconditional statements are used to write definition. A definition is a statement that describes a mathematical object and can be written as a true biconditional. Okay, so here we go. A polygon is defined as a closed plane, figure formed by 3 or more line segments. Poly, that means many faces. Okay, so here we go. So polygon, then non-polygon. Anything that's considered non-polygon, then that'll be considered curve or external line segment, or things that's not connected, or three-dimensional space figure. So anything that's connected with vertices, okay, so it's always considered polygon. Or things that's being connected with the line segments form the corner, so those are the polygon. Triangle is defined as three-sided polygon, and quadrilateral prefixes qua, 4. So 4 sides polygon. Okay, triangles, quadrilaterals. So writing definition as biconditional statement, so more practice. A pentagon, it's a 5-sided polygon. Okay, how would you rewrite it as a biconditional statement? A figure is a pentagon if and only if it's a 5-sided polygon. A right angle measure 90 degrees. An angle is a right angle if and only if its measure is 90 degrees. Okay, so that's some of the example. A quadrilateral is a 4-sided polygon. A figure is a quadrilateral if and only if it's a 4-sided polygon. The measure of a straight angle is 180 degrees. An angle is a straight angle if and only if its measure is 180 degrees. So here's some of the problem for the practice lesson quiz. You guys can finish that as part of the ticket exit problem. Okay, so for the conditionals, if an angle is right, then its measure is 90 degrees. Write a converse in its biconditional statement. Here we go. If an angle's measure is 90 degrees, then the angle is right. Biconditional, an angle is right if and only if its measure is 90 degrees. Determine if the biconditional's two angles are complementary if and only if the above acute is true. If that's false, give a counterexample. False, because those two angles could be 30 degree, 40 degree. Write a definition. An acute triangle is a triangle with three acute angles as a biconditional. A triangle, it's acute if and only if it has three acute angles. So it's pretty basic. It's just like what we've been talking about, biconditional statement. Okay, so that's it. So thank you for watching the video today. So once again, if you guys do like those videos, so please subscribe to the channel so there are more valuable lessons coming up. Okay, so thank you for watching it. I'll see you next time.